like doing this whole get to see everyone around the world all at the same time in all the different time zones.
Hi. So I'm Jonathan, and this is Observability for modern Spring applications. And I'm one of the engineers from the Spring team, as well as Tommy, who is my co-speaker today, and who will give you like a very nice demo later on. But yeah, let's get started. So let's talk about what is observability and also why do we need it. So for this talk, we will define observability as how well we can understand the internals of a system, which doesn't need to be software, but for us it is usually is, based on the outputs that it provides. So you have a software, an application that will provide meaningful information about what happens inside of it, and hopefully you will get some meaningful data about that. And if you want a less fancy definition, you can just say it is data about your application. Basically, that's it. And also, let's talk about why do we need observability, because that may be a more important question. So in one word, this is because of complexity. Because today's systems are insanely complex. We don't have a Linux server running with Apache and MySQL anymore. We are living in a cloud era. If you have heard about the star architecture or big ball of mud, that's what I am talking about. If you haven't, please look at this picture. As far as I know, this is Amazon's infrastructure 10 plus years ago. Now the situation is much worse. And every single dot on this image represents an application, and every single edge between those dots, those are the communication between them. So if you need to troubleshoot something when you have this scale, that's hard. Also, on this scale, I have bad news. Something is always broken. But just to continue on that thought and giving you more bad news about these environments, because of this complexity, they can be very, very chaotic. This means that you turn a knob a little here, and in another region, applications can go down. Also, we need to deal with unknown unknowns because we cannot know everything. There are issues that you can face in production that you know that can appear. Those are the known unknowns. There are also known unknowns, which are the issues that you know that you don't know everything about. And there will be unknown unknowns. Those are the issues that can bring your production environment down, but you don't even know that they exist. And we need to deal with them. And also these environments are also tricky because in them, things can be perceived differently by different observers. And this means that maybe everything is 100% fine from your perspective, but at the very same time, maybe everything is broken for your users. So let's continue on this thought and talk about why do we need observability from the business perspective. And observability usually helps us to reduce losing revenue from production incidents. And it usually helps us to lower the mean time to recovery for these incidents. That means that you will have, you need less time to fix these issues once they arrive. And also people will need less specialized knowledge for root cause analysis. This means that not everyone needs to know about every single detail of every single application. So this you will need some kind of a shared method of investigating across the system. People should know the common tools that you are using, but they don't need to know the special tiny bits that are necessary to investigate every single application in your infrastructure. Also, you can quantify user experience just simply by measuring them. So you don't need to guess about like what the users are doing or how do they or what they are experiencing while they are using your application. You can actually measure them and get data out of your observability backends. So with this, let's switch on to Tommy, because he is going to give you a very cool demo about this, which is kind of simulating a real life scenario. So Tommy, it's you.
Yeah, thank you, Jonathan. So we got a demo here for you today. It's called the Tea House app. It is a completely open source set of demo apps. You've got the QR code there if you want to scan it and take a look after this talk or after you finish with all of the talks today. And you can run all this on your own machine. We've got a Docker Compose file there, so you can run all the services you need. And it's got 3 Spring Boot apps in there. Jonathan, can you go to the next slide? Hopefully everyone's gotten a chance. If not, the slides will be available, or we can send out on social media the link. But yeah, so this is just to give you kind of an overview of the architecture of the demo. It's 3 Spring Boot applications on the latest Spring Boot 3, latest major version was released last year. So we've got a tea service, tea leaf service, and a water service. And the tea service is calling these other 2 services, and your end users are the ones interacting with the tea service via a UI. So with that, let's go ahead and actually try this out and make some tea. So we can switch over to my screen. There we go. Hopefully everyone can see my screen now. Okay, so this is the Tea app that we showed earlier, and you can see that we've got this amazing UI here. You might think that we probably paid a lot of money to have some amazing graphics work and UI designers come up with this UI, but I assure you that this was 100% made in-house by the Spring Observability team. So, we don't just do observability, we also do UI sometimes, in case anyone's looking for it. So we've got this tea here. You can choose your tea leaf. Let's go with a green tea and maybe small because it's kind of late here for me. And you steep it and everything works. So that's basically how it works here. Depending on which tea you use, it's going to call the tea leaf service and it's going to get a different tea leaf back, and you can choose a different amount of water, and it's going to call those services. So everything seems fine. It's all fast. There's no errors. So that means that everything must be done and we can just call it a day, right? Well, if you were paying attention when Jonathan was talking earlier, he said that just because you have a certain experience doesn't mean that that's the experience for all of your users. So we don't know. Maybe the experience is great for all the users. Maybe everyone's experiencing things just like I am, really fast, no problems. But in order to actually verify this, we need to go look at our observability data. So I'm going to switch over to Grafana, which is an open source tool that can visualize observability data. And this is just one of the options that are available to you if you're using Spring Boot and you're using observability powered by Micrometer. We support sending observability data to many different backends, and you can visualize that data with all kinds of different tools. So this is just one example. It's not the only option you have. You can use many different tools. And we have this T API dashboard that's already pre-built. This is, again, in the GitHub repository. So if you want to try this out later, this will be included. And on here, we've just got some dashboard panels. Maybe I can zoom in so it'll be a little easier for everyone to see. So this is visualizing the latency. So we can see the T service, which is the service that users are interacting with. Here's the latency distribution visualized here, where the topmost line is the max latency, and then we've got the 99th percentile and the 95th percentile. So we can see our latency distribution here. You can see we've got a green heart, which means we don't have any alerts firing. We have some alerts set up for what we think is acceptable latency for our services. And so if I go back, we also got this throughput dashboard, and this is important because you want to know if your application is receiving traffic right now, how much traffic it's receiving. And most importantly, you want to know whether the requests are successful or you're getting some kind of error. And you can unfortunately see the heart here is not green. It's red and broken. We've got an alert firing. And you can see that we have some error rate going here. So you can see we've got a load generator running in the background that's sending requests to our application, sending a variety of different requests. And most of those requests are successful, but we can see that something's failing. And so we need to investigate why so that we can get rid of this error and so that we can make sure that our users are back to having a good experience, fast requests successfully completed. So I had all successful requests, but now that we've looked at the dashboards and we can look at the metrics that are based on all user requests, these are aggregated across all of the requests we're receiving from users. You can see that the experience that I had doesn't match the experience of everyone. So how do we look into this? Well, we can look over here on the latency graph, and you can see there are some dots outside of the lines, and these are what are called exemplars. So the lines in this dashboard are based off of the metrics, which are aggregated observability data across all of our users. But in order to dig into and find the root cause of this, it might be helpful if we can look at a specific request that has the specific problem that we're looking for. So we're looking for a request that has an error, and we want to, if we click on one of these exemplars that has an error, so like this one, you can see has an outcome server error, and we can click on this button, query with tempo, and this is going to jump from the metrics to the distributed tracing observability data. So while the metrics is an aggregated view of all of the requests across all of your users broken down into different categories like successful and unsuccessful, the tracing data gives you a view of one specific request from one user at one time. And so I found one that had an error because we're trying to figure out why the errors are happening. And now you can see visually all of the time that was spent on this request and all of the different services and which service was calling which in kind of this hierarchical view that matches what we expected from our system architecture. And if we wanted to see that visualized more, you can see based on this tracing data, it's built that we've got this T service, and then that's got a HTTP client that's calling the water service that then has a connection to a database, and then that database connection is calling a query, and then it's processing a result set. And so you can kind of see this visually, this hierarchy in this node, and that matches the hierarchy that we saw in the architecture that we presented to you earlier. So this is important because you intend to build a system in a certain way, but how do you verify that the system's actually behaving in the way that you expect, that things are actually calling the things that you expect? So tracing data is one way that you can do that because you're looking at what really happened in production as opposed to what you planned to happen in production. So we can see here the T service calling the water service, T service calling the tea leaf service. And you can see on the left-hand side, there's this error mark. So this is showing that there was an error somewhere in the span. So each one of these lines here represents one span, which is one unit of work within the entire trace, which matches from the beginning of a user request until it was returned to the user. So we can see the water service, there's no error mark there, so the error is not there. Tea leaf service has an error, so there was some error within this tea leaf service. And we can click on any of these spans, and then we can look into more information. We can get span attributes, and this has some metadata to help us figure out what went on. So tracing data at its most basic level is to give you a hierarchy and to give you information about how much time was spent in a place. But right now we're focusing on why an error happened, not so much the time. And so that's where maybe looking at these attributes will give us more information. So we can see that this tea leaf service is getting a request, and this is the URI, and we can see that it's resulting in an error. And we can even see an error message, resource not found, tea leaf name English breakfast. Okay, well, that's giving us a pretty good clue of what's happening here, right? There's a request for tea leaf named English breakfast, and the resource is not found. And we could even go into and look more specifically. So this is representing the HTTP server request that was received at the tea leaf service. But we know that the tea leaf service has a database, and we can see the database connection database query, and the result set processing. So we can even see in the metadata here, you have the exact SQL query that was used to call the database and try to retrieve the tea leaf. And you can see in this result set span that there were 0 results from the database. So it's querying the database, and unless the query is wrong, then it seems like English breakfast is not in the database. But if the query were wrong, then we would expect errors on other things. And we tried other things and they all worked. But if I try English breakfast now, oh, now I see that I'm getting the error. So before I just happened to not try English breakfast, but if you're manually testing things, it's hard to try every combination. And the good news is that you don't need to, because if you look at your metrics, then you can get aggregated data and you can find these kinds of errors that are happening in some specific combination that you might have not tried by yourself. And so now we were able to drill down into the tracing data, find the root cause of the error. English breakfast is apparently not in the database. And that was good, and that was pretty easy, and that was quick and all. But let's say that for some reason you needed more information that wasn't included in the tracing data by default, which by the way, all of this tracing data, all of these metrics are available out of the box. In Spring Boot 3, we did a lot of work on making sure that our observability instrumentation, all of the different Spring projects were as good as they could be, and we've been improving on that since. So all of this tracing data, all of the metrics that you saw earlier we're not adding, and you can check in the source code that we didn't add code specifically to get this tracing data or this metric data. This is provided out of the box as long as you have the right configuration, the right dependencies on the class path, and then Spring Boot will auto configure having these things. So you don't have to do a lot of work to get all of this. We got this out of the box. But so let's say that the information that was available out of the box wasn't enough. There's something else that you can do here to drill down even more into your observability data. So you can look at related logs. So if you've ever had a service, or you've had a lot of services running in production, you have a lot of instances of them, and you have a lot of traffic going to those services, then you're probably gonna have a lot of lines of logs coming out of all of those services. And so when something's going wrong, I think a lot of developers' instinct is, I want to check the logs. But this can be really difficult if you just have one feed of all of the logs from all of your applications, from all of your instances, from all your different users and every request that they're making. It's really hard to find the specific log that you want. But here we've jumped to a specific trace that we know has an error, and we know that this represents something that we want to fix. Well, if we click on this button here, we can look at the related logs. And what this is doing is it's finding all of the logs that correspond to this specific trace. So we're going to be able to look at the logs that correspond to one user's request and filter specifically by that. So this is pretty neat. I mean, we've got stack traces if that were something that we needed. In this case, I don't think it is, but depending on the type of issue that you're having, it might be. And we've got all of that information available. But I think basically what we're going to see in these logs is, well, we're going to see that, we returned a 500 error, but the underlying error was this resource not found, which we already saw in the tracing data, but now we can have a stack trace with that if you wanted to go and see exactly where in the code that was happening. Okay, so I'm going to, in the background off screen, go ahead and just insert into the database the English breakfast tea leaf that's missing. Okay, I've done that. Let me go over to the UI here again. All right, so English breakfast, let's steep it. Okay, and we can see that's being successful. So everything's great now, there are no more problems, right? Well, again, we don't know, because remember, my experience doesn't necessarily represent all of the user's experience. And that's why we have metrics aggregated across all of the requests that we're getting from users. So we can confirm that it didn't just work for me this one time, that it's actually fixed for all of the users. So if we go back to our dashboard, the T API, and we're gonna have to wait for a little bit for it to update. So the metrics are being collected from all of the running applications. They're just running on my laptop at the moment, but could be collected from all of your instances running across your production system. And so it looks like it's updating, and we can see that the alert just got cleared. So we no longer have a high error rate. That's great. But we want to see it go to 0. There we go. Now we have 0 errors, and the load generator is still sending requests, including requests for English breakfast. And those are now all working. So that's pretty neat. We were able to see how we demonstrated that just because the UI works for me doesn't mean that it's working for everyone. We demonstrated that, okay, we could see in our metrics that the error was happening for a set of our users. Then we could check out the tracing data and figure out exactly, or we could find a trace that represented one of those errors that we were seeing. We could find the root cause of that error. We fixed the root cause of that error. We verified manually that English breakfast was now working. And then we went back to the metrics to confirm that it wasn't just working for me, it was working for all of my users. This is the kind of flow that we see. Now, I came to the dashboard to check that there was or wasn't an error. We don't actually want you to be staring at a dashboard all day. We know that you've got features to deliver and bugs to fix. And so normally you would have like a PagerDuty or a Slack alert or some kind of way of being notified of when there's an issue so that you don't have to just stare at a dashboard, because that's not fun for anyone to do all day long. But in this case, I came to here and saw that there was an error, and we fixed it and we verified it. That's great. So everything's fine. We should be able to just go home now, except I'm noticing we had this latency graph before and everything was looking fine. You know, it was looking fine earlier, and now there's this huge spike in latency, and now we've got some alert going for high latency. Well, we might not know what to do, except we just did this process. Now we just have to do the same thing, but try to find the issue for the latency issue now. And again, we've got these exemplars on here. And so you can see where the exemplars are on the graph represent a specific request that took that much time. So you see we've got like the max and the 99th percentile. So we can check on one of these. Here, we'll check on one that's close to the 99th percentile. So we can see this was slow, and then we can click on the same button, jump to the tracing view. So now we've got the tracing view of this. And I told you before that tracing is mainly about seeing hierarchy and how much time was spent within each service. And you can see the spans representing the unit of work that was done in each place. Well, now that we're actually investigating the latency issue, you can very quickly visually see where the time is spent. So last time when we were looking into the error being returned, that was in the tea leaf service, and we could see a nice error mark. Well, now there's not an error. The requests are successful, and we can even try it out ourselves if we wanted. So we can see it's noticeably slower. Before it was almost instant. Now it feels a little sluggish, right? So we can see that for ourselves, but we can see that there's no error. It's successful. It's just slow. Well, we still want to fix slow problems, because time taken in request is users that you're losing to your competitors as they're waiting, or they're at their cart ready to check out, and now it's taking too long and they thought about it too much, and now they're not going to make that purchase. So time really does correspond to money in business, and we want to fix those problems too. So we can see the tea leaf service, it looks very small compared to the water service. And now the sizing here is all relative. So if it's not about absolute time taken, this is about relative time. But we can see relatively, there's a lot more time taken in the water service than there is in the tea leaf service. And we know that this is representing the HTTP span, and this is representing, it says connection. This means the database connection. And so we can see that most of the time is being taken up in this database connection, whereas the tea leaf service is connecting to a database, and it's only taking 5.5 milliseconds. But over here, we're taking almost 65 milliseconds. So there's something slow about the database. And again, because you can look at the tracing data and it's got this metadata attached to it, you can even see like the exact query that's being run. So maybe you could take this to your database administrators and you could have them analyze the query plan and see if there's something wrong with that. Maybe an index needs to be added. Maybe something changed about the data. You can investigate from that perspective. But now you've narrowed down that there's something wrong with the database connection for the water service. And that should be really helpful in going forward. And maybe you could do something even on the application side. Maybe maybe the information that you're getting back from the water service is not something that changes all the time. Maybe it only changes every hour. Maybe it only changes every day. In that case, you could cache the result on the application side and avoid paying this cost every time you get a request from a user. So there are different ways that you could go about solving this problem, and it depends on your specific business case. But having this observability data available and being able to visualize it and have it connected between the metrics and the traces and your logs is how you're going to be able to very quickly identify and narrow down where the issue is. I mean, imagine if you had to just look at logs and try to figure this out. So we can see the logs for this request, and you can see the query that was made. You can see that it was successful. You can see the query time was really low. You can see the connection time was high. But sometimes it's nice to see it visually because you want to see it in the context of the whole request. Is this connection time high? Well, maybe. You kind of have to consider it in relation to other things. And with the tracing data, you can see that very quickly, how the water service database compares to the tea leaf service database. So I will spare you actually fixing this by adding caching or by doing something to fix the performance in the database, but I just wanted to show you how you can very quickly get to the root cause and see things in context and know what's going on. And this is all connected. So you've got your metrics, again, to recap, that are aggregated across all of the requests that you're receiving. This is giving you the big picture, telling you what's happening amongst all your users. And then the tracing data is how you drill into a specific request from a user and see what happened in one specific case. And with this exemplar feature, it's easier to get more quickly to the specific kind of request that you're looking for, whether that's a slow request or a request with errors. So I hope that was helpful. And again, this demo is on GitHub. So if anyone wants to play with this themselves and try it out, feel free to do that. And if you have any questions, contact us. We'll have some contact information at the end. We'll be here available to chat. And yeah, that's it for the demo.
Cool. That's great. So let's talk about what we saw in Tommy's demo, and also let's recap that a little bit, and also let's talk about how to do this in a Java or JVM application. Can we switch to my slides? Okay, cool. So let's talk about logging metrics and distributed tracing a little bit. This is also called the 3 pillars of observability, and this is what we mostly saw in the demo. And please remind you that when we gave the definition of observability, we did not say that observability is logging metrics and distributed tracing. It is much more than that. There are a lot of other components here, but these are the most common ones. So let's talk about these a little bit. So logging is basically trying to tell you what happened in an application. Sometimes it can also tell you why something happened. For example, if you can figure out from the stack trace or from the log message, that's sometimes useful, but sometimes it is not. And it is doing it by emitting events that are usually human readable. You can grab them, but please don't do that in production. You can use a log ingestion system, basically what you saw in Tommy's demo. And metrics, on the other hand, it should tell you what is the context of these events. And it is doing it by aggregating the data, and it can tell you how bad things are, or how good are them. So for example, if you see an error in your logs, from that error, you don't really know what is the best radius. Is everything down, or was that just one error in the last 30 seconds? Or the same thing, if you see a latency number 140 milliseconds in your Tomcat access logs, is it good or bad? For some people, it's pretty good. For some people, it will be very bad. But metrics can tell you that, hey, for example, the maximum latency is around that number. So maybe that number is bad for you. And the last one, distributed tracing, it should answer the question of why something happened, and it is doing it by recording these events with causal ordering, so that you will know, like, hey, this event was caused by another one. They have this like parent-child relationship. Those spans that Tommy showed me, those are doing this. So you will see that, hey, this HTTP call happened because of this HTTP request was received, and so on. So let's talk about a little bit and go deeper. What do you want to do or what you can do if you want to implement some logging with Spring? And this is, I guess, true for like the broader application frameworks as well. So it is not just for Spring, but Spring Boot is coming pre-configured with SLF4j and Loopback. And SLF4j stands for like a simple logging facade for Java. And it has a simple API that you can basically plug logging libraries in and out. And Loopback is one of these implementations. Like, it is natively implementing the SLF4j API, and that's what Spring Boot is coming with. So if you just have a like default Spring application or Spring Boot application, it will use SLF4j and Loopback to do the logging. If you want to use log4j2 instead of Loopback, you can do that as well. You just need to exclude a dependency and include another one. It's very simple. With that, let's move on to what you can do if you want metrics. And this is also true for broader applications, not just for Spring. But Spring or Spring Boot comes like auto-configured with Micrometer. And Micrometer is a dimensional metrics library on the JVM. You can use it in any Java-based or JVM-based applications. It doesn't need to be Spring. And we like to say that it is like SLF4j, but for metrics, because it has a very simple API that is kind of similar. It's you are using an API independent, like an independent API, and you can configure the metrics backends that you want to use later. And you can use, you can basically pick and choose which metrics backend you want to use, or you can use multiple backends at the same time as well. And as I mentioned, like Spring Boot Actuator will bring in Micrometer for you. And also Spring projects are instrumenting themselves using Micrometer. And there are many, many other third-party libraries and also frameworks that are using Micrometer to instrument themselves. These are the common web frameworks like Quarkus, Micronaut as well are using Micrometer to instrument themselves. We have instrumentation support for Hibernate, Hickory CP, HTTP clients, and so on. So the picture here is very, very broad. And when we say that Micrometer is kind of like SLF4j, but for metrics, this is what we mean by that. These are the backends that are supported by the Micrometer team. There are more backends that you can use with Micrometer. Those are like supported by third parties, but we have a pretty broad spectrum of metrics backends that you can use with your application if you are using the Micrometer API. And with that, let's move to distributed tracing. So what you can do if you want to use distributed tracing. And this is a little bit of Spring specific, not entirely, because you need to make a distinction here. If you are still on Spring Boot 2, which let me remind you, it will go end of life in this year for open source support. So if you are using Spring Boot 2, you should use Spring Cloud Sleuth. But if you are using Spring Boot 3, you should use Micrometer tracing. And Micrometer tracing is very similar to Spring Cloud Sleuth because it was created from Sleuth. So basically, Micrometer tracing is Sleuth without the Spring dependencies. We just copied Sleuth over to the Micrometer umbrella, removed the Spring dependencies, and also fixed a couple of things, renamed packages, and so on. So while for using Sleuth, you will need Spring Cloud and Spring Boot. For Micrometer tracing, that is not true anymore. Micrometer tracing does not depend on Spring. So you can use it on a non-Spring application as well. And yeah, people are also using it in other frameworks other than Spring. And Both of these libraries, what they are trying to do, they are trying to provide an abstraction layer on top of tracing libraries. Again, this is kind of like the SLF4j situation. Like Micrometer Tracing has a common API, and if you're using that API, you can basically switch between tracing libraries under the hood. And right now we support two of them. One of them is called Brave from the OpenZipkin community, and this is kind of like the default solution because Brave is a mature project. It is there for a long time. And there is also OpenTelemetry, which is a newer project. It is under the CNCF umbrella. And since it is not stable yet, it is kind of experimental in our eyes right now. And also we have instrumentation support for like most of the Spring projects and also like a lot of the third-party libraries. And since these two like tracing libraries, they support various backends, this is because Micrometer Tracing also supports them as well, because Micrometer Tracing just like delegates these calls to these tracing libraries. So with that, let's talk about another thing, which is called the Observation API, and a little bit about this effort called Spring Observability. Now, the idea behind the Observation API is that if you want to instrument a component, you usually need to do it multiple times, unfortunately. So if you, for example, want to add like application logs, you need to add like these log statements. If you want to add metrics, then maybe you need to increment a counter or start and stop timers. If you want to add distributed tracing, you need to start and stop spans. Maybe you also want to implement log correlation, context propagation, and so on. But the interesting thing here is that if you want to get these signals out of a running application that Tommy just showed you, you might need to instrument your application like multiple times, especially if you're instrumenting your own business logic that you wrote and there is no existing instrumentation for that. And the situation can be even worse if you want to add like custom things. For example, what happens if you want to write an audit table when like an error happens, or you want to have some kind of like an error store where you want to send all of the error events to like a custom backend and so on. So with all of these, you need to do these things multiple times. And the idea behind of the Observation API is to reduce this and instrument your application only once with a common API and get multiple benefit out of it. So what you can see here is like one like a very, very simple usage example for this Observation API, which was released in Micrometer 1.10, which was like last November. So it is not very new. It's almost like a year old. But what you can see here is that I am not basically instrumenting a thread.sleep call, and I am not telling the application that I want metrics or I want tracing. I'm not starting timers or dealing with spans. What I am doing here is I am starting an observation. And then I am signaling an error to that observation. And at the end, I will just stop that observation. And that is basically the instrumentation bits or building blocks I'm using here. There are more, but I guess it could be a valid question. Okay, but how can I get like metrics, tracing, or whatever data I can out of this? And the answer to that is called observation handlers. Now, the observation handlers I think that those are kind of the heart of the Observation API, because what you can do is that you can have and implement these handlers and register them to your observations, into your observation registry. And once you register them, then every time you start an observation, you stop an observation, signal an error, or do other things, these handlers will be notified. So they can act accordingly. For example, here you can see on the first place there is a meter handler here. And the meter handler in this example could, for example, create a timer when somebody, and create and start the timer when somebody starts the observation. And when you stop the observation, it can stop the timer and report the data. The tracing handler, similarly, it can start and stop spans and also like attach the error to to this span, and so on. And by the way, we have these two out of the box available for you. There is a default meter handler in Micrometer, and there is a default tracing handler in Micrometer Tracing, and they just do what I just described. Also, if you want to do like custom things, you can use a logging handler or an audit event handler, or basically the word is your oyster. And this example on this slide is a little bit of like a simple or simplification. We have this observe method on the observation. What it can do, it can actually get a method reference, and it will do almost exactly the same what I showed you on the first slide. Start an observation, signal an error, and stop the observation. And you can even simplify this more with this @observed annotation, and that will do the same. So with that, we basically like instrumented most of the Spring portfolio. And this was like back in November, but since November, we did a lot of improvements on this. For example, we improved exemplar support because like Prometheus that is supporting exemplars, it did not support exemplars everywhere. So we contacted the Prometheus team, we opened a pull request, and now Prometheus is capable to do that. So we are going to have this improvement in Micrometer as well in our next release. And in the meantime, we did a lot of observability improvements in the Spring portfolio. We will have better context propagation and automatic log correlation in Spring Boot. Right now you need to use a property, but it will be automated from Spring Boot 3.2. And also we added a bunch of additional instrumentation. So right now, if you use like the scheduled annotation, you will not get like instrumentation for that out of the box, but with the next release, you will. And this is true for R2DBC and JMS as well. And we're supposed to like investigate virtual threads and Project Loom, most probably in the next, not in the current release of Micrometer that will come out in November, but after that, and also coordinated restore at checkpoint. And hopefully we will have a new and better improved like docs site. So with that, I guess that was our talk. Please, let's continue the conversation. You can reach us like on Twitter or like other social media. Tommy and I are usually there and like listening. And also Micrometer has a Slack channel or a Slack workspace. So you can visit us at slack.micrometer.io as well. And also we are here in the chat as well. So if you have any questions, please let us know. And yeah, we will discuss that.
Yeah, we're always happy to hear more about how everyone is using observability in your work, because I know that there's a lot of different ways that people are using observability, and people are at different stages of their journey. Some places only have logging, some have some metrics, some have logs, metrics, tracing, and even more stuff. So we'd love to hear about what you're doing. We'd love to hear about if you're using Micrometer, even if you're not using Micrometer, and any features that you're looking for or any issues that you ran into. Please let us know. We'd love to hear from you.
Also, we had a question in Pigeonhole. So the question is, can we use this to capture front-end metrics like user actions? And if you are thinking about that, like user interactions with the backend, you can capture those with Micrometer on the backend. But since Micrometer is like a JVM library, you only can use it in Java applications or like JVM applications. And if you want to capture those like on the UI, then you can use the client library of your backend, like a Prometheus client, for example, or you could also use like other implementations like OpenTelemetry as well. Hope that that answers the question.